Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I will be talking about diffuse programming today, and for us, diffuse programming is these things that come from the convergence of a broad network accessibility, a rich digital environment, and a vast set of information. And out of these three things put together, we can create new things, and I will try to, in the first time, demonstrate the kind of thing we are able to create today, and then in the second time, I will try to show you how we program these new things. And I think that this talk will be radically different from what Don has been saying before, because here we won't be using types at all. We will be using really dynamic programming languages. So it will be just the other facet of the same thing somehow. So first, if we consider computers, the evolution of computers, but not from the perspective of their increase in performance or things like that, but from the perspective of the kind of entity you can deal with your program, with your computers. The first computer were able to basically deal with numbers. So you were able to do arithmetic with computers. Well, they were able to deal with numbers, but also with times, because times has always been a notion related to computers. Then, if you consider the first personal computer, we were able to deal with colors, drawings, sounds, and typically the only sensitive things it was really possible to do with such a machine was to play. But that was still another kind of thing we were able to do. Then, roughly speaking, on a very rough timetable, 10 years later, when we acquired PostScript and laser printer, we have been able to use our personal computers for printing stuff. So it was a new kind of application. We have been able to create something of the real life, a piece of paper with something written on it, automatically produced by the computer. Then, one more time, 10 years after that, with the rise of internet, we have been able to use our computer for communicating. Computers became an extremely powerful means of communications. So new kind of application has been possible, the mail, the web, and so on and so forth. Then, with a 1 gigahertz machine, more or less, approximately, we have been able to deal with multimedia with our computers. We have now, all the cameras are digital cameras. We are just listening for electronic music. Videos is the same, is now electronic. And maybe 1 gigahertz machine was the first one that you were able to use for creating a product of your everyday life. That is, you were able to use this machine for burning CDs, a real object that you can take in your hand and put in the radio player of your car. So first time we have been able to create something. And now we are just facing something totally new, which is a new world opened by the fact that we have computers that are now aware of their environment. If you consider a typical machine of this new world, such as an iPhone is provided with a full set of sensors. You have a compass, you have a metal detector, you have a presence detector, you have a GPS, you have, and so on and so forth. And so now, because these new computers are aware of what is going on around them, we will be able to create new applications. And that's the kind of application we are interested in. So, in terms of computer science, what are the characteristics of this application we want to program? Well, first, they will be fundamentally distributed. We want to run applications that run on several computers located in different places in the world, so massively distributed. Distribution and parallelism, because our application will be running on several machines at a time, and we will have to implement synchronization and things like that. But the specificities of the kind of application we want to program is that they will be strongly heterogeneous, because maybe we want our application to be running at the same time on the cloud, on a grid somewhere, and maybe at the same time on your phone. So don't expect the same kind of performance or possibilities from a grid of computer and from your phone. We want our application to be versatile and imprecise, because if you are using a huge set of machines, don't expect everything to be reliable. You will have some faults, networks breakdown, and so on and so forth. So you will have to be able to, you have to be ready to program in this new world. And then maybe the last and important point is that we want to program imprecise application. And for us, that's something really new. Before, we wanted computer applications to be producing very precise stuff, very precise number, very precise answers. And nowadays, things have changed. For instance, consider what you are doing when you are using Google or any search engine. You are asking an imprecise question, and out of this imprecise question, you receive an imprecise answer. And it's exactly because this is imprecise that it is so useful. If Google was requiring something very precise to be able to answer you very precise, then it will be totally useless. So we want to be able to deal with this kind of imprecision. And then we want our application to be rooted in the real world. And I will try to demonstrate what I mean by rooted in the real world with a bunch of applications. And I cross my finger. I hope everything will be going fine because I have some trouble with the network, as usual, I may say. So, sorry. Excuse me. This is the real world. And this is actually just a map of the place we are right now. And what's interesting here is that, oh, I'm sorry, I have some, okay, something is mixed up, but never mind. So this is where we are here. And the important point here is that I am not telling my computer that I'm here. I'm asking my computer where I am. And my computer is not necessarily provided with a GPS. So the question is, how is my computer aware of my location? Well, actually, if you want to know where you are, you just have to ask Google. And in general, Google tells you where you are. So here, it's just Google that tells me that I'm here. So that's something surprising and maybe a little bit frightening, but that's the way it is. And here on this map, what you see is that we have a whole bunch of information, such as the fact that here we have a bank or maybe an ATM machine, I don't really know, and here we have a mailbox. And that's very interesting. How do we get this information? And actually, it's because this application I'm running here is based on OpenStreetMap, which is a collaborative application, which means that you and I can contribute to this application. That is, we can go and be walking on the street, and when we cross an ATM, we just grab our phone, we press a button, and we increase the OpenStreetMap database that now is aware that at this very position there is an ATM. So in order to be able to create such an application, and you see the map is very precise because you have information about traffic lights, name of the street, railroads, and a whole bunch of things. And the fact, what we need to be able to create such an application is that you and I have to be provided with devices that are always connected to the network, always available. That is, you can just grab your phone that is in your pocket, it is ready to be used, and you just press one button. And because this is connected, you can go and enrich the remote database. And all this is just transparent. But in order to be able to create such a collaborative application, you need a whole bunch of infrastructure because you need a network, you need a reliable network, you need devices, powerful enough devices, a whole bunch of things like that. And then on this map, here are displayed just 3 tweets, which are just small messages that are sent by users that are normally geolocated. But there is something confusing with the map, so I just zoom out a little bit and just to show the Paris area. And now I show the tweets that are posted in Paris, and I geolocate them on this map. So this guy has sent this tweet in this location, more or less. And how do we get this information? It's simply because when you send a tweet, if you send it with your phone, probably your phone is equipped with a GPS, so we know where the tweet has been emitted from. And if we don't, if the tweet contains a geolocation information, such as Tour Eiffel or something like that, then we just ask Google, where is the Tour Eiffel? And Google tells us where is the Tour Eiffel, and we're able to insert the tweet at the correct place in the map. So once again, in order to build such an application, we have to be able to reuse a whole bunch of information that are provided by different providers. So the next application, and that I will demonstrate, is that first I have said I want to be able to write application rooted in the real world. And so far, I have not demonstrated anything related to the real world, but just representation of the real world. It was just a map. So now I will try something different. I will grab my phone, and I will press this button. And now you see that my slides are moving according to the move of my hands. So it means that actually my application is just aware of what I'm doing right now. So, and you see, this is really a diffuse application because I'm using my phone and my PC, and all that is interacting. So this is an application that is really rooted in the physical world. So let's keep going with other examples. these things that now you see everywhere on mostly any advertisement on the bus stop in Paris, is it something of the physical world or is it something of the cyber world? Well, it's something just at the boundary, something that you use for entering the entering the cyber world from the physical world. And so if you grab your phone and just take point your phone to this QR code, you will see a whole bunch of interesting things. Excuse me?
It's the side of the media, isn't it?
Yeah, normally it should be the side providing my slides, but maybe your phone is not powerful enough to display my slides, so maybe you are redirected to an area. Or maybe I got confused when I created this QR code, but you will see the code that generates this stuff afterward. So something in between the real world and the cyber world. That application. So I imagine that most of you have been are aware of this kind of things, but I presume that some of you are not aware of the kind of application I will demonstrate. So this is just a small animation that shows the propagation of the flu in Europe. So when we have no information, the country is left in gray, and when we have information, the country is displayed in red if there is a huge flu propagation, and in green otherwise. So this is not a very fancy application. You have seen this kind of thing a lot of time. But what is very interesting with this application and what is very new is that the way we collect information has nothing to do with actual doctors and hospitals. The way we decide that there is a flu somewhere is just by inspecting the Google logs. And actually, if in a country a lot of people are asking information about the flu, it means that the flu is in this country. And that's the way we create this application. So it's just a regular animation, but computed with totally new means. So the question you may ask about this kind of thing is, first of all, does it make sense to do this kind of stuff? So, well, I don't know. I'm in no position to judge, but the people that have created this way of computing the flu seems to be very serious guys, and according to our academic standards, they have been able to produce very high-level papers about that. So probably it has some sense. Then the real question is that, okay, it is serious, but is it reliable? And you see on this graph two different curves. The blue one is the one collected by Google, and the yellow one is the one collected from the actual facts, asking doctors, asking a hospital. And you see that actually the two curves matches, which means that, yes, just inspecting the Google logs is extremely valuable. It provides a real result. But the interesting point is that extracting the blue curves, you get it just like that. While creating the yellow curves, you have to go and ask doctors, so it takes a couple of days or even a couple of weeks. So by just checking the Google logs, you have an information that is reliable, but you got it very, very, you are able to get it very soon. And so you win a lot of time just checking what Google provides.
So looking at the data, it looks like it's a better pre-predictor than the Sentinel's one, because each epidemic comes with, it rises before and drops after.
Yes, maybe, maybe. Okay, and so what is very interesting for me here is that somehow it's a proof that the web has bootstrapped, which I mean by that is that the web is just something invented by human beings, and now the web, by just looking at itself, is able to provide new information about mankind somehow. By just inspecting what we are doing on the web, we are able to say, yes, there is a flu here, which is something just out of nowhere. So the web has bootstrapped. That's a good news. Okay, so now connected world. So for this, I have implemented a small demonstration, which is here, which is somehow an application that looks like what you probably use for reading the news on your phone. But I have implemented a version here to demonstrate, and I have added some extra features on this application. So what we can do is we can grab a newspaper, such as this one. So I have a slow network connection, so it will take some time. And then, okay, I am aware that the title in this French newspaper are this and that. Maybe you are not very interested by this one because it is in French. So let's check, let's say, the New York Times. Okay, so we have a bunch of information. And you see here, for instance, that I have the French translation of the title of the New York Times. And if I'm interested by this paper, I can ask the translation of the whole, I hope of the whole article here translated in French. And I can have automatic translation in Spanish, in Japanese, in whatsoever. Now, imagine that I'm just commuting in my car, so I cannot read the newspaper. So maybe I want my phone to read the newspaper for me. So I will click this button. Can you hear it? Okay. So my phone is reading the newspaper for me. So I hope that at this point you are really confused and you really no longer know where the application is running. Is it running on my laptop or is it running on my phone? Well, actually it is running on both. Well, no, this application is running on my phone actually. And I can ask other stuff to this application. For instance, if I'm particularly interested in Iraqi, I may ask this application. Oh, sorry, I pressed the wrong button. I may ask, are there other articles about this particular subject? So maybe no. Iraqi youth is maybe too special. I will try something else. Financial crisis. Yes, we will find something. Yes. Okay. So here are other articles that are related to the main subject I have just been reading before. And once again, this is just a very small application I have created just for being able to give a demonstration, not today, but it's very simple demonstration. I have been able to do it myself and only by myself. So I have an application that is able to collect newspaper, relate articles of the newspaper, read the newspaper, translate the newspaper. And it's just 1,000 lines of code or even less than that. So it just means that we are able to reuse a lot of stuff that are provided by others. And our whole purpose is to make this kind of thing possible and easy to be done by almost everyone. So what about us in all this, us as computer scientists? Well, this is always the same story. We will be writing programs, so we will be needing programming languages. And the idea is that for one particular application field, probably you need one particular programming language or family of programming language. So if you want to write floating point applications, then probably you will use Fortran. If you want to program this old-fashioned computers, then maybe you will use this old-fashioned programming language. If you want to control an airplane, this is a serious stuff, so maybe you will be using a dedicated programming language, such as STRL here. And so the question is, now you want to program diffuse application. And the game is not to program individually each of these devices, but what you want to do is to program an application that embraces them all at a time. That's a new game. What language will you use? And you will be doing different stuff than what you were doing before. Now the question is not really to reduce or to implement efficiently such algorithm or such whatsoever. Now you want to do different stuff, which are, you want to write applications that collaborate. You want to aggregate information you grab from here and there. You want to reuse. You want to change. You want to pervert. You want to orchestrate. You want to adapt. You want to just glue together things. And you need programming language for just implementing this glue. That's what we are trying to do. So our proposal, just one step in this direction, is a new programming language, which is called Hop, that somehow helps you doing all these kind of things. So I will present Hop, somehow a little bit a very high-level overview of the language, and then I will show you some examples, how we program, basically how we program the demonstration I gave so far. So the idea is that you want to program in an ubiquitous world, and for that you already have a platform which is there, which is the web. So the very general idea of Hop is we will use the web as a kind of virtual machine, and what we will do is that we will compile Hop into the technologies of the web. That is, you won't have to be using HTML explicitly, but we will compile things to HTML. We will compile to JavaScript. We will compile to et cetera, et cetera. That's what we are going to do. So a little bit of architecture. This is a traditional web application, a three-tier application. You have clients, you, I, actually our web browsers. We have servers, Google, Bing, whatsoever, and we have databases. In Hop, we use a slightly different settings because here we add a broker, and the web browser now contacts the broker, and the broker, if needed, will contact a remote server. So the broker is a very convenient place where you can implement mashup. You see, a mashup is typically a collaborative application. You reuse information provided by different servers. So For instance, for the application where I was geolocating the tweets, my broker was contacting OpenStreetMap for the base map, was contacting Twitter for the tweet, and Google for geolocalizing the tweets. Then for this broker, is also a full-fledged web server, so you have several persons that can be connected to the broker and use it as a regular web server. This broker is aware of its environment. So typically, your broker is able to communicate with your phone. When I was moving the slides, that's what I was doing. Or your broker is able to communicate with your Hi-Fi system. So for instance, you can grab your phone and raise the volume of your Hi-Fi system, or you can just say, no longer play the music in the kitchen, but play it in the living room, or things like that. And the reason why the broker is able to communicate with its environment is either because each of these devices is also provided with a broker and two brokers can communicate, or because since in Hop we have a full-fledged programming language, we are able to implement protocol that lets the broker communicate with these devices. So typically for communicating with an Hi-Fi system, we have implemented a dedicated protocol that is a regular protocol for communicating with Hi-Fi. And so we are just able now to control these kind of devices. So for the application where I was moving the slide, I was just using this kind of architecture, just 3 people, my laptop here, my laptop running the broker, and my phone also running a broker communicating with my laptop. So now an important remark is that you program in this world, and actually you have different communications and different size of all these arrows. Maybe OpenStreetMap is in Europe, Twitter is in California, my phone is just close to my PC, and you don't really care about the size of these arrows. You just program as if they were all the same, and that's the way it is, that's the way it works. So now programming the web. Obviously, there is this problem of this difficulty of the web, which is that in order to be able to create a web application, you have to be efficient with a whole bunch of different programming languages. And this is extremely annoying because you have to learn all this language, and also because it's extremely difficult to have a clear understanding of an application if it relies on different formalism. It's difficult to debug, it's difficult to reason about it. So that's something we consider we have solved with Hop, because we will be using only just one formalism for the entire application. That is, you configure the web server up to the GUI will be implemented with just one formalism, which is Hop itself. So no longer this Tower of Babel of different languages. But still, we are facing some difficulties when we are writing our application. So if we make a very, very short overview of what you can expect on web programming, first, we had the Web 1.0, which was really very easy because you had a server and a client, but the entire application was only running on the server. The only thing the client was able to do was just to display text and pictures. And the only interaction with the user was just click. You click on one page, and you were redirected to another page, and so on and so forth. So very few interaction, program just on one end, very easy. With a dynamic web, with a Web 2.0, things start to get complicated, because now your program is running on 2 different sides, the server and the client. And unfortunately, the 2 sides are not using the same language. 5 minutes? OK. They are not using the same language. So now you have to be able to enforce a coherence in between an application that uses different formalism. Now, if you consider the diffuse web, things are even worse, because you are no longer using just one server, but a whole bunch of servers. Some will be out for some time. Some will be malicious. And you will have to be facing this situation. So you now, in the diffuse web, you are living in a very dangerous world, but also very exciting world. You will be able to create new applications because of the fact that you will be reusing all this information. So main characteristic of Hop, it's a multi-tier language, which means that you will program the server side and the client side in the same programming language. And that's why we will be using only one formalism. That's why we think it will be simpler. Then we offer security by compilation, and then we also start offering orchestration. But I will just present this part today. So what about the language? And I will be very, very quick on that. So Hop is a functional language, such as F#, but a different branch of functional language because we are strongly relying on dynamic type checks. So we do not verify type at compile times, we verify them at runtime. Otherwise, there are a lot of similarities in between F# and hop. But hop is also a programming language for the web, which means that we will be able to reuse all the technology of the web in hop. And actually, we will be compiling hop, for instance, to HTML. But in hop, HTML is a value. So you will be able to write programs that will manipulate HTML as any regular value. So I will skip this part, and since I'm a little bit too slow, and I will just show you some examples of some programs. So this is your first hop program here. It really looks like HTML, but we have added an extra open parenthesis in front of each tag, and we have replaced the closing tag with a closing parenthesis. That's it. The other difference, of course, is that this is HTML, but here we no longer have JavaScript, we have hop here. And when you want to write something that will be executed on the client with respect to something executed on the server, you just add this sign here. This means that this expression will get evaluated only when the user will click on this table data. Since HTML is a value of the language, you can just manipulate all the value and use all your iterator and constructor over these values. So typically, we are able to create the same program using a list and iterating over the list and just constructing the table dynamically instead of programming it statically. And here, this I variable, which will be successively bound to 1, 2, 3, 4, 5, will be used on the server side in order to create the HTML document you want to use, and on the server side when the user will click on one button. So, okay, now I will assume that you know enough of hop in order to be able to understand a little bit of the implementation of the application I have demonstrated before. So this is the implementation of the OpenStreetMap application. So the idea is that since hop is a full-fledged programming language, you are able to create your own tag. And typically, this is a tag that I have created, which is provided by this package. And this tag actually is just a piece of HTML document that contains div and span and things like that. But you as a programmer, you have an abstraction, and you just see that this as a new HTML tag that you can use in your application. So now what we do is we create a map with a certain size, and then we bound this map to a variable that we use on the server side to create our main page. Then we add a button here, where am I? And when I click on that button, I ask my web browser, where am I currently? And when I get this information, I use my map and I recenter it using the information I just got. So this is the whole implementation of the first demonstration I gave. So the second demonstration, the one where I was moving my slides, well, on the phone, I just write a very, very simple web page that is just listening for events, which are orientation events. And when the phone receives such an event, it contacts a hop broker and says, OK, I have been moved. And the only thing the server will do, it will propagate to all the clients that are interested in the fact that the phone has moved. And on my laptop, what I'm running is just I'm waiting for this kind of event, this orientation event. And when I received it, that is when my PC received it, it's just changed the style of the current slide by just changing its orientation. And that's it. That's the entire implementation of the application where I moved my slides. So the QR code, how do I implement the QR code in hop? Well, that's very easy. There is a nice guy that is providing this JavaScript package for us. This is actually a rather complex code that I don't really understand, but it's not really a problem. The only thing I have to reuse is that particular function that creates a QR code. And if I want to use this JavaScript code in hop, well, I have to do something like that, which means that in hop, I will reuse JavaScript. And then I use any JavaScript function or JavaScript value as if it was a hop thing. There is no distinction in between hop and JavaScript. So here is just the fact that I'm reusing the JavaScript value. And once I'm done with this module, you as a user, you can grab my module, and now you have a new HTML tag which creates a QR code. And then if I run this on my browser, on my web browser, I get this QR code. That's it. Maybe the last thing to conclude, how I have implemented my application about the through propagation. Well, if you go to this URL, you get this information by Google. It's just a style sheet information, and it's just a propagation of the flu in Europe. So if you want to create the application, you just have to parse all this line, which is something very simple, the kind of things we teach to our first-year students. You extract one line, you parse it. Out of this line, so this is the information relative to each country here. Out of this line, you simply construct a new URL, which is this one. And this URL, if you fetch the document as this URL, in returns, Google will provide you pictures drawing the map of Europe with all the country in different colors. So out of this URL, you just get these pictures. So implementing the demonstration was just to go from one picture to the other, and that's it. So this is the whole implementation of the animation of the flu propagation in Europe. So it's something like 15 lines of code. And I think I'm done. That will be all for me. So this concludes my talk. Thank you for listening. So